Today we would like to look at a subtopic that is future value annuities that end early. Sometimes you might decide not to continue with your monthly installments before the date on which the agreement was stipulated. The agreement says 10 years, but because of some issues, you decide maybe to terminate this annuity much earlier. So we are going to look at how we deliberate on such type of situations. There is not really much for me to explain except to do two examples, after which work will be given. Example 1 reads, Peter pays a monthly amount of 1,500 into an annuity, earning an interest rate of 9% per annum compounded monthly for 30 years. At the end of the 30 years, he stops his monthly payments but leaves the money in the account for a further 2 years. Calculate how much he had in his account at the end of the 32 years. Now, this question calls for our ability to deal with questions of this nature by simply drawing a timeline as usual. So we are starting at T0 and we are ending after 3 years. So you will notice that from T0 up to T360, we have an amount of 1,500 being put in each and every month until the last installment, which was made at T360. So this is an annuity. And we, from the question, have heard that it's going for 30 years. And of course, 30 years times 12 gives us 360. That is the regularity of our time of payment and the regularity compared to that of interest must be the same. And here it says 10%, here it says 9% compounded monthly. So there is no changes to happen there. So the future value, we have our installment and we know the formula. We substitute each other terms that we have, and because this is not being terminated here, Peter decides to leave this amount in the account for a further 2 years, which means we have got 24 months when this amount is growing compoundedly. So we all know the compound formula. A is equal to P bracket 1 plus I, all in brackets to the power N. So we are going to make sure that the amount at T360 becomes our P, which is the future value we calculated above. And then it's going to grow compoundedly according to the compound formula. And then we have 1 plus 0,09 over 12 to the power 24. When you use your calculator properly, this is what you must get, 3285489,41. We move on to example number 2. Tandy opens a savings account and immediately deposit 1,000. Immediately. Take note of that. Immediately, it means the formula must be changed into the account. 1 month later and thereafter, on a monthly basis, she invests 1,000 per month for a period of 3 years. 1 month after her final payment of 1,000, Tandy increases her monthly payment to 2,500 and continued these monthly payments for a further 3 years. So the period is increased now to 6 years, but we have got different annuities. In this case, you cannot mix the annuities, because we said in an annuity the amount we are paying every month does not change. If it changes, it means it's a new annuity. We are now going to treat them separately, as you will notice from our timeline. The interest rate during the 6 years is 10% per annum, compounded monthly. That's good. Compounded monthly. Calculate the future value of this investment at the end of 6-year period. We are starting at T0 and we are ending here at T3. Or we are ending here at T36. Now from there, we do another 3 years, but we are starting 1 month after this last 1,000 that we are paying. We increase it to 1,500. So we shall have another annuity starting from T37 up to T72. So here we go. We shall have 2 annuities here that are determined by what we are paying. So F1 is the future value in the first situation. F2 is the future value in the second situation. Substituting all that we have, remember here it was immediately 36, we add 1, so it's 37, because it happened immediately. So it will be to the power 37. We divide by that, we have a value, and here this one again is now to 2,500, and it's for 3 years, and we are starting 1 month after, so it's in order. When we do the second one, we don't change this one, it's not altered. Then we have that. These two when added together, but don't forget this one ended here. It means if you leave it in there, it will grow compoundedly to the end. So for a further 3 years, this future value which we calculated here grows compoundedly. That is why we have this multiplied by 1 plus 0.1 over 12 to the power 36. This is saying the amount we had, which is the future value, grows compoundedly from T36 up to T72. And we substitute all the values, we end up with 162,601.64. After you have listened to this video, you do the following. Exercise 5, that's your classwork. You are doing numbers 1, 3, and 4. And then the same exercise, we take our homework. We are only doing question 2. So this is your homework and this is your classwork. I thank you.